Hey there, this is Max Doolin. I'm the founder of the Spokane Cyber Cup, and I'm really excited to go after this event. I love teaching students how to hack, I love seeing the faces light up, and a lot of these things are real bugs that people find like in their day-to-day job. So, if this is your first year, welcome. If you're second, third, fourth, I don't know, 100th year, I guess it's only sixth event, but also welcome. Normally, I don't make this kind of video. Typically, everything is blind before you get to the CTF. But I think this is difficult enough to where I'm okay giving you guys a little bit of heads up and a little bit of help. So I actually work at a Web3 security company or blockchain security company where I help secure some of the various protocols in the space. And it's pretty rough. There's lots of money at stake with this sort of thing. So security is taken very seriously. So first, we're going to talk about the basics of Solidity, which is the smart contract programming language that is used on the Ethereum blockchain. I'm then going to talk about some Remix, which is a Solidity IDE that's really nice. And then finally, I'm going to talk about some CTF specific things that I want to go through that I did in order to make this challenge a little bit easier. So let's get into it. There is a list of contracts here, and I'll show you how to put those in here. But for now, we just have this DAO contract. And this is actually the final challenge. You probably can't find the bug by looking at it because it's fairly subtle, but I think you'll enjoy it when you see it later. So this is what a Solidity smart contract looks like. We have the Pragma or the Solidity version at the top. We have the keyword contract and the name of the contract DAO at the end of it. And then a lot of it looks fairly similar to JavaScript. We have a function declaration, and then we have a visibility modifier. If you use something like Java, this is a fairly common thing as well, where you can specify who's able to call it. In Solidity, there is external, in public, which are both called from the outside. There's internal and private, which are not callable from the outside. The difference between those is not relevant for these contests, though. What else did I want to talk about here? Variables and storage. So in a regular program, you just store stuff in memory, but we need some sort of permanent storage. But it's a blockchain. We can't just store it in a database. So the way this works is we have a global memory called storage that we can write stuff into. For instance, we can have a Boolean of type or named A or B or something like that. So this is defining something that can be globally accessed as a variable within the smart contract. Addresses are weird. So you've probably never seen the address type because it's fairly unique. When we say crypto, the crypto actually comes from cryptocurrency or cryptography. And the cryptography is really important here. So the address, actually, when you make a call to a smart contract, you are using cryptography. So you're using what's called a digital signature, which you can think of as your John Hancock. Hey, I'm okay with making this call. This is what I want to do with it. And the address is effectively, I think it's the hash of the public key, and it's the first 20 bytes. So it's an identifier that is linked to a particular user in a way. It's kind of like a username in a way, but in smart contract land. On that notion of things are a little bit weird, you'll see these message.value, message.sender. In Ethereum, this message.sender is the caller of the contract. If you've written websites before, this is like the logged in user in a way. And the message.value is the amount of ether or Ethereum that you are sending in the call. In Solidity, this is kind of weird, you can natively send assets with your call. In particular, the native asset of the call is ether. So by sending that value with it, you're able to transfer ether to other smart contracts or other users directly. The other part of the native content for Ether is the gas. So unlike regular programs, which if you're on your computer, they can run forever, blockchains are decentralized, meaning that a bunch of other people are executing the code. What this means is that you need to pay for that. And this gas is what you pay for it, is how you pay for it. So somebody executes your code for you and they need to get paid. And that gas is the payment for that, which means that smart contracts aren't technically Turing complete because you can't actually execute arbitrary programs. If it runs too long, the program will fail. The other difference to smart contracts is they are atomic. It's either it succeeds and state is updated, or it fails and no state is updated. For instance, this require statement is effectively an assert in other languages. And if we hit this require statement, and with the sent being set to false, then every update that had been made to any contract will be reverted completely back. It's an all or nothing kind of thing. So this is really strange if you've never seen it before. Because if you've written a program and you update a variable, but then you exit after that, that variable will still be updated. But in the context of a Solidity smart contract, the revert just reverts everything. All the state will get updated. Cool, so that's my basics of Solidity. Good job getting through that. So now we're going to talk about Remix. Remix is this IDE that I'm playing around with. If you want to compile your code, you can go here and click compile. However, I highly recommend just specifying auto compile so you can see when stuff's airing out and not working. With smart contracts, you have to deploy them, and this deployment is adding your smart contract code to the blockchain. If you see this tab here, you can see deploy and run transaction, and you can click this deploy button to deploy that contract. Now, you need to make sure you're deploying the right one if there are multiple contracts stored in the same file. In Remix, you can have different locations where your call is being made to. For instance, they have this really nice thing called the Remix VM, which is effectively a local blockchain in your browser. However, for the smart contract series, you're going to want to update this to external provider and then change this link to what we set it to. Alongside deploy, you can use what's called the @address. If there is a smart contract already deployed, then you can use the @address feature, and you will then have that smart contract callable by these little blocks here. So, for instance, if I click deploy smart contract, when I click on these blocks, I can check the balance of the contract. I can check this Boolean. I can make state editing calls, for instance, as well. So the best way to interact with smart contracts is definitely going to be through this big box right here. It allows you to do a lot of different things. Allows you to provide parameters. Oh, my voice squeaked there. That was nice. It allows you to provide parameters there as well. Debugging is really hard in Remix. You can get some errors that are nice, but a lot of the time it's just going to be like out of gas, transaction failed. So a lot of the evaluations need to be, okay, I'm executing this code step by step in my head, what's going on. If you see an error message, try to figure it out, but a lot of times it doesn't give you very good error messages. The final thing about Remix that I think is helpful is how to send Ether to a contract. So if I want to call deposit here, I am just adding Ether to the contract, but increasing a global storage variable that increases my amount. And I could theoretically withdraw it in a minute. If I call deposit, I want to send Ether with it. And this little box here is how you do that. So I call deposit, and now you can see that the Ether balance has gone up. And I can call withdraw, and it goes back to my account, and it's back to 0. Cool, so we made it through some basics of Remix, and now we're going to talk about the CTF specific things. There's a lot of different contracts. I believe there are 5 different challenges for this event, for this contract series. And I don't want to have to copy this code manually. So there's a really cool feature in Remix that allows you to upload code or download code to your local environment using a GIST. So if you go to the home tab here and then go to GIST and you type in the URL for the GIST that we will give you at the event, then you're able to download the same environment I have and have the same smart contracts and everything, which is awesome. So that's the first thing you should do when doing these challenges. The second thing you should do is you should specify the node you want to interact with. So like I said here, right now it's on the Remix VM, and that's the default. But we want to set it to an external provider. Right now I'm running it locally, but in the challenge this will have a separate URL. So you'll click OK, and now it's going to that external provider, so you make the contract calls. If you have this set incorrectly, then you won't be able to do any of the challenges. And if you refresh the browser, then you have to fix this as well. For the smart contracts, there is a list of challenges. So every student needs to get their own instance of a smart contract. And this is because we don't want people interfering with each other. So you can do create smart contract instance on this website, which will then give you a contract address that you can use. If you then go back here, and we're in there, we can go to add address, which is loading the smart contract and allow us to interact with it. And now, if we look at the balance, we can see that it actually does have 5 Ether there. That Boolean, ignore that. We can check the win function as well. On every challenge, there is going to be a did win button, and there is a did win function on the contract that we're interacting with, this win here. So you can always see if you won or not. If you want to check to see if you won, you can do submit. And if you satisfy the criteria of the challenge, it will output the flag. Otherwise, you don't get the flag because you have not solved it. So this isn't everything there is to know about smart contracts, clearly, but I hope this is a good starting point for this challenge. I think this is super fun. It's totally niche, but I think you guys will enjoy it. I'm really excited for the event. I'm really excited to see everybody. If you have any questions relating to smart contracts or CTFs or anything about the event in general, feel free to reach out to me. Thanks for listening. See you soon.